So up till now, when talking about trig with, in grade 10, grade 9, whatever, we've only talked about right angle triangles. Last year, we emphasized sine, cosine, tangent, and used Pythagorean theorem lots. So we can find angles, we can find sides, and any right triangle using those things. So let's just do very preliminary. How would I find the angle A there? Or I mean angle X, sorry, in A. Well, let's see. From angle X, we have the opposite side and we have the hypotenuse. So what trig ratio can I use to find X? Okay. So sine of X equals 8 over 14, opposite over hypotenuse.
2 over 2. We do like 2, can you cut 8 and 4?
Oh yeah, that's fine. It's still the same proportion. So you could call this 4 over 7. That'd be fine. You don't have to though. So then to find X, we're looking for an angle. So we're doing the inverse trig ratio. Now, still in this course, this is not the case next year, but in 20-1, we're still only using degree mode. So just make sure your calculator is measuring in degrees, not in radians. It'll say, if it's one of these, there's like, normal, float, auto, real, degree. If your calculator's been reset and it's a fancy calculator like this, it defaults to radians. So just make sure that you go into mode and change that to degree from radian, okay? Otherwise, you're going to find some wonky things. Second sine of 8 over 14. So this one, it asks the nearest whole number, so we can say x is 35 degrees. Yeah? No debate so far. Not yet. So we did, not yet. Okay, how about this next one then? So now I have an angle, but I'm looking for a side. And let's see, from this angle, I have the adjacent side and I have the hypotenuse. Okay, so what do I set up here?
Tan.
For adjacent and hypotenuse? Cosine of 40 degrees equals adjacent, 19, over hypotenuse, x. Okay, so then x equals 19 over cos 40. Now this time we're looking for a side, so we're just doing the straight normal trig ratio, not the inverse. So 19 over cos of 40 will give me the side length, which here, x, it asks the nearest whole number. What you'll see more often, you'll usually see angles measured to the nearest whole number, and side lengths are more often measured to the nearest tenth. But we're told the nearest whole number here, so 24.8 can be 25. And we don't have units, so 25 units. Cool. That part, nice review of last year. So now let's use that to look at this triangle. Now this triangle is not a right triangle. And truthfully, you can break any triangle into right triangles by drawing a right angle in the middle. So in this case, this 75-degree triangle has been cut in half into a 55 and a 20. And we're asked to find the length of BC. We're asked to find this whole thing. Or we could say BC, that's equal to BD plus C, right? It's those two pieces together. Now, would I be able to, how would I be able to find them? Which one should I start with? I should do that.
The 12.50 and 20 classic.
Oh, sure, yeah. Nice. Yeah, and we recognize, yes, we can find this angle. Feel free to if you want, right? You have 75 and 35. But we don't actually even need it, right? We can find BD without having anything other than what we have. So in this case, we have BD. We'll do that first, I agree. So BD, that one we have the 12.5 and the 20. So what can we set up to find that? Oh, okay, I can get you. All right, so BD. What trig ratio can we set up to find BD? Sine? Why?
Because we can find that perpendicular also for both sides.
Nice. Yeah, so let's just call this x. Call this one x, call this one y. BD is fine, but so if we said we're looking at opposite hypotenuse, you're absolutely right. Then sine 20 equals x over hypotenuse. 12.5. So x equals 12.5 sine 20. 12.5 times sine 20. So we get here 4.275. And on one like this, I'm going to keep more information than I need. I'm asked to answer to 2 decimal places, so I should keep at least 3, maybe 4, right? Then we're not going to run into any rounding issues at the end. A good rule of thumb is while you're working, keep as much information as you can. You need to make sure you have at least 1 decimal place more than you need while you're working. If you're going to be just adding, if you're multiplying, you need to be even more careful than that. Yep.
Won't we like take out the value of the perpendicular like on this one?
Pardon me?
You took out the value of base, right?
Yeah.
But I just said that perpendicular.
Here's the issue. So take a look at this triangle here. We have parts of a right triangle, and in this case, the theta is the same spot as this one. Right, like the top is our unknown. So in this case, from theta, hypotenuse, opposites, adjacent. If we were looking from here, and right, 75 plus 35, that's 110. This is 70 degrees. So if you're going from 70 degrees, I guess we could have just said 20 plus 70 is 90 also. But the 70 degrees, that would then be adjacent and hypotenuse. But it's always in relation to the angle we're talking about. Okay, so we found x. Now, there's a bit of trouble, though. I don't see any way to figure out DC yet. I don't have any side lengths. Would there be a way to find a side length that I can use in this triangle on the right side? Well, let's just think about this. I have no information about this. I have no information about this. Okay, great idea. Let's find a middle. So I want to find AD. That'll be a good intermediate step. So AD, and you're absolutely right, Sid. AD squared is equal to AB squared minus BD squared. All right, Pythagorean theorem. So 12.5 squared minus the answer I just got, 4.27, blah, 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 squared. Now that I'm realizing I have to square this and do the subtraction, I'm going to take like literally my whole answer to carry it through and use as much information as I can. So if I go 12.5 squared minus answer on this second minus answer squared, give me a little more information. So AD squared 137.972, blah, blah, blah. So that's my answer for AD, right?
No, you're
Thanks. So AD equals 11.746, blah, blah, blah. So that's this. Okay, now I think I can figure out this next one. I can figure out DC. So if I have AD and I need DC, I have either of those angles. How should I set this up? I see the only piece of this triangle I don't really care about is the hypotenuse. I have this one and I'm looking for this one. We should be able to do a tan ratio.
Yeah.
Tan is the one that uses opposite adjacent. And we can use either 55 or 35. Notice if I use 35, this is opposite, this is adjacent. If I use 55, this is opposite, this is adjacent. So for y, for DC, I need to use, let's say, tan of 35 equals opposite 11.7 over piece I'm looking for. So y is equal to now I take what my values was, answer, divide it by 95, and I find that y equals 16.775. Yeah? No? Maybe so?
Mm-hmm.
So then how do I find BC?
Oh, you have them.
Yeah? Yes, sir?
Should not be tan 55 degrees.
Yes. No, so you could have done either. But I chose to go with this as, or sorry, I chose to go from 35. This is opposite, this is adjacent. tan of 55, this would be opposite, this would be adjacent. There's actually a really good case here to figure out. Pardon? We don't have anything yet. Remember you're in the class? We're about nothing? Great. Okay, so in this case, let's just think about this triangle. This is a really good question being asked here. So for this triangle A, B, C, you can kind of always think about sine, cosine, or tangent of two different angles. So in this case, if 55 is our angle of reference, what's opposite of 55?
Right.
And what's adjacent to 55?
Right.
So tan of 55 equals this over this. What about 35? Well, 35, opposite is here, 80, and adjacent is this, y. And if you take a look on your trig table, which I know you have in front of you here, look at tan 35 and tan 55, so you can figure out how they're related. You'll realize if you do one, as long as you flip it, one is the reciprocal of the other. That's where that relationship is related. Okay, so anyways, that means that BC equals 4.25 plus the 16 plus whatever. So BC equals 21 point, yes, two decimal places, so 0.5. Okay, now, we haven't done anything new yet. Everything we've done, you can do in grade 10. Right? It's a little bit of a clunky problem. Actually, taking 3 steps to find one side of a triangle is a bit annoying. But none of it used anything new. It took some problem-solving skills. It took cutting the triangle in half, but nothing was really new. I think the natural next question that we're always asking is, that took me a lot of work. Can I do it easier? Right? Is there some way that would simplify this? And the answer is for sure. The answer is absolutely. So if we have a triangle like that, in this case, let's take this obtuse triangle. And just for some labeling notation to make things easier, we did talk about this in 10 a little bit, but when we're talking about like angles, we use capital letters. When we're talking about sides, we use lowercase letters. And we name the sides based on the opposite angle. So like angle A is opposite from side A, angle B opposite side B, angle C opposite side C. It's actually pretty important here because it's not like we can say the hypotenuse anymore on a triangle where there's no right angle. Right? You could say the longest length is always going to be kind of the biggest one, whatever. The one opposite the largest angle will function sort of like your hypotenuse. We don't have Pythagorean theorem exactly with a triangle that isn't a right triangle. Although tomorrow we'll look at something that is where Pythagorean theorem came from that may help. But today we're going to talk about something called sine law. And this is directly a relationship between the length of a side and the sine of the angle. The length of the side and the sine of the angle. And to prove the sine law, which is that the side length over the sine of the angle is equal to the other, side length over, and you can kind of use this for any 2 of the 3 pairs. So let's say I have side A, side C, and angle A. I could then find angle C. Or let's say I have, angle A, angle B, and side B. I could use that to find side A or whatnot. It's basically a thing of if you know 3 out of these things, you should be able to find another one. So let's prove others. Let's go back to this. We're having troubles here. Let's go back to the same situation. So this is triangle ABC. Place with AB on the x-axis. Origin's A. In this next one, let's flip the origin is B. So first of all, in one, the relationship sine A, well, that would be CD over AC, right? Opposite over adjacent. And if AC in our new notation is B, we could say sine A is equal to opposite over hypotenuse, or CD over B. So then CD, so in this situation, CD, that would be equal to B times sine A. And how about the sine b? Doing the same thing for sine b, like for number 2. The sine of b in this relationship, that's sine of b, that's CD over A. CD over side A, which was CD over BC. So then CD equals A times sine B. So then it follows that in this case, B sine A, which is equal to CD, is also equal to A times sine B. And if we divide both sides of this equation by sine A times sine B, let's do this. Divide the left side by sine A over sine B. We end up with a B over sine B, because the sine A is canceled. And if we do this to the right side, divide by sine A over sine B, we end up with A over sine A. Right? A over sine B divided by sine A over sine B. Sine B is canceled. So we find out that B over sine B equals A over sine A. And if we did the same thing but rearranged the triangle so that AC was on the x-axis, we would find A over sine A equals C over sine C. So we have this proof of the sine law. And don't worry, I don't expect you to reproduce the sine law. This is just showing why it works. Doing proofs of a situation like this is a little beyond the scope of this course. However, if you take a bunch of university math, you'll just get to regurgitate proofs over and over. So look forward to that. But here we have this relationship. This is the key of today's lesson. Now let's see how we use it. So triangle ABC from this example is shown. I don't want to do all that ugly work. So let's see if I can set this up and find BC, find this bottom leg. Now if I was labeling this again, BC, what would that be named in our new naming notation? What lowercase letter could we name the bottom? Yeah, A. And we also have C. Okay, so I have angle C, angle A. Could I find angle B if I needed it?
Yeah.
Okay, that'd be easy, nice. I have side A, or I'm looking for side A, I have side C. Okay, so let's first of all set up the proportion that I know. So I have that 12.5 over sine C, or sorry, and I have C over sine 35. That's a relationship I know. That's the C, say, side C over angle C. I have the angle for A, so sine of 75 should be under A. And if I have a proportion like this, suddenly solving it is pretty easy. In this case, A equals 12.5 times sine 75 divided by sine 35. That'll give me value A. Setting up a proportion and solving for it, we're still familiar with that? Like missing this, times both sides by sine 75 and find A? Yeah, good. So 12.5 times sine 75 divided by sine 35. Drum roll, please. At least I had one person point on things. Whoa, it's so surprising! Same value! I really like this. That was pretty simple. Doing all that, right angle stuff, that seemed kind of hard, but this really simplified here when I was doing the information. Well, how about in a situation like this? So I'm going to use sine law. Maybe just while I'm getting used to it, let's write out again. You probably noticed when we were looking at this on the last page that we actually had it written either with the sides on top or with the angles on top. Doesn't matter which one you use. They're the same formula, right? If the relationship between this is equal to the relationship between this is equal to the relationship between this, then the reciprocals will also be equal to each other. So it doesn't matter which way you do this. I would suggest that usually most people will find it easier if you put the one you're looking for on top. You don't have to, right? It's perfectly fine in proportion with what you're looking for on the bottom. But it seems like mistakes happen less often if the thing you're looking for is on top. So that's like my trick. You can do it either way though. So in this case, I'm looking for angle ACB. I'm looking for this. I'm looking for angle C. That's what I want to know. So I'm going to say, let's see, I have A, I have side A, I have B, side B, right? This is side B. This is side A. I'm asked to find angle C. Shoot, that doesn't match up very well. What will you do here? I don't know how I'm going to find data here. I don't know.
You can do inverse.
Well, if we're just like connecting sides. So I have both angle A and side B. So that's like a pair. Good. I also have side B. That should make it easy to find angle B. If I find angle B, is it easy to find angle C? Okay, let's do that. So first of all, let's figure out angle B. So this is like our intermediate stuff. So angle B, or sine of B, over side B, equals angle A over side A. So to find B, we see that sine B equals 6 times sine 110 over 9.4, and then you'll just inverse sine whatever you get, right? So 6. So B equals, it asks in the nearest degree, and since I'm just adding and driving here, I can just say this is 37, 36.8, whatever. Approximately 37. And this is 37 degrees. Now I should be able to find C. And C equals 180 minus 110 minus 37. So 180 minus 147. There's that little intermediate trick just of thinking, okay, if I can find this, then I can find this. And with angles, just remember, finding angles, if you have two of them, the third one you can always just find automatically. So that's often like the thing that's kind of the small trick is you're asked for one angle, but you actually need the other one. How about this? Now I'm asked to a perimeter of a triangle. Survey measures a baseline, which is 440 meters. Okay, I'm told a number. When I read that number, I automatically label it. Right? One of my jobs, the word problem is not in math, is just set up the situation with the drawing. So whenever I read the thing, I put it on my drawing. Now he takes measurements from landmark R to R from P and Q, and find out that angle QPR, okay, QPR, okay, that's that one, is 46 degrees, and PQR, 75 degrees. Okay, my triangle is nicely labeled now. I'm asked to find perimeter. So what am I going to need to find perimeter? What are the missing pieces of information I still need before I have perimeter? Yeah? Angle R, sure. Angle R for Sine Law, yeah. And then how about to actually find perimeter? What do I need to have? Yeah, both sides. Okay, so angle R, what's that? From this, the three angles out to 180. So what's our?
46 plus 75 minus 180.
Yep, that'll give you a negative number, but it's still the right value for you. Still the actual values. Fine.
57.
Yes. Wait, 46 and 75. That would give you 11. No, it did 9.
59.
Yeah. Okay. And if that's the angle, now how do I find, or which side should I find first? Let's call this side R, let's call this side Q, let's call this side P. So I need to find both sides Q and P, find this value. Let me go to P first. P over sine 46 equals, we'll use our R relationship here. So R as 440 over sine 59. Cool. Agree? Disagree? Sleeping? Going once. Going twice. Big lunch is in. Guess that must be the excuse. Okay, someone help me set up Q. How am I going to find Q? This is not a right triangle. Don't you say you're not a right triangle?
Q is equal to sine 7.
Oh yeah, okay. So do the same thing. Q over sine 75 equals 440 over sine 59. Yes, you could have done this also with your p-values. Just recognize your p-value you have approximated, so use more decimals if you're going to use a p-value. So Q ends up being 440 times sine 75 over sine 9. Now, just a quick check here. I found these two measures. I'm going to add them all up. I just want to check, does it seem like I've labeled this right based on what I know? And what I'm really asking is, does the longest side sit opposite the biggest angle and go on and on? Because that's a reasonable assumption, right? Wherever the biggest angle should have the longest side opposite it, and the smallest angle should have the shortest side opposite. So let's quick check here. Okay, my biggest side is 495, my biggest angle is 75, nice. My smallest angle is 46, my smallest side is 369. All of these numbers are relatively close, and the values are relatively close. Okay, I think these are right. I think these have worked out pretty well. So now, to find perimeter, that's just addable sides. So add up P plus Q plus R. It asks something here. That's kind of a big application problem with Sine Law. But, you know, find one side, find the other, get the whole thing. So, of course, then the natural question that goes with that, what about the area? We've got all these sides filled in. How could I find the area? Now, what's the area of a triangle again? Base of that over 2, yeah. Now, I have base. Actually, I have 3 possibilities for base. What's the height, though? If we're defining a triangle, height is some line that's perpendicular to the base. It goes from the base to the top. So in this case, if I'm using 440 as my base, which is a great decision, perfectly fine, then the height will be whatever this measure is. Possible. How can I find it? Seems really hard.
Can we do that?
I have a trick. I have an idea. If I went just and used a right triangle trig, last year grade 10 trig, and I see this length, I have some measures here, and I have an angle. I could use like sine of 46 is this over this, or sine of 75 this over this. You could also use, well, sine's gonna be what works best here. So I think I'm gonna do that. I think to find the height, and I'll just do this up here because I have all the information on this page. I'm gonna go height. That's what I'm gonna call this measurement, H. So we'll go sine of 46 equals opposite, which I don't know, over hypotenuse 495.8, blah, 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 827. So H is equal to 495.8277844 times sine 46. So H here's 356.6686, and we call it base 440. So area. Your voice, you moved that so fast. Yeah, it's because I was expecting you to do it on your calculator. Base times height over 2. Don't worry about it. Base we called 440 meters. Height we called 356.668. Blah, blah, blah. Divided by 2. Area. So the nearest 100 square meters. Notice it's not nearest 100. It's the nearest 100. It's determining that it doesn't matter even closer than that. Saying get within 100 square meters. So if the area is 78,467.1, blah, 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 it wants us to round that to the nearest 100, 78,500. Why might you round to like nearest 100 or something like that, rather than going to the exact base of this? I would guess they're selling flooring, not like the nearest meter, but maybe the nearest acre, or maybe the canton or something like that. You want to know about how much you need. Now for today's assignment, this is a one-day lesson on Sine Law. We won't be doing this tomorrow. But I think in general, this is a lesson where at first it feels weird. Practice, I think by the end of the day you're going to be feeling really comfortable. I've just given you 2 questions that are grade 10 stuff, and then from 3 to 11 is all moving on to the newer stuff. So I'd say just 1 A and C, and then do questions 3 to 11. Sound good? All right. We'll start out in here, and then yes, you'll be able to do it in that one. Okay?